Now we're going to look at triple integrals. One thing that makes it harder to set up triple integrals is that it's just generally harder to draw the pictures because it's harder to draw pictures in 3D. And drawing pictures is really useful when trying to set these problems up, so we'll, do our best. So I want to calculate the integral of xyz over v, where v is the region bounded by the paraboloid z equals x squared plus y squared, and the plane z equals 4. So if I look at what that's going to look like, I'll do my best to kind of draw this out here. It's going to be a paraboloid, so it's going to kind of look like a parabola. But it's also going to have these kind of circular cross sections. And specifically at 4, it's going to intersect this plane. We'll go ahead and draw a nice solid because it's intersecting this plane. Z equals 4. So this area between those is going to be the region we're integrating over. And kind of what I want to think of here is most naturally what seems like my top and bottom function. Well, it seems like, well, first of all, let's find some intersections. Because whenever we're setting up integrals, we're going to find intersections and then do top minus bottom. Okay. So what are my intersections? Well, where does z equal x squared plus y squared intersect z equals 4? That's going to be on the curve. On the curve, 4 equals x squared plus y squared. Well, technically, that's not just a curve. Technically, that is it has a z coordinate of 4. But, I don't really care. That part doesn't really matter. What really matters is that it's going to intersect when 4 equals x squared plus y squared. And that part's going to come up later. But first, we're going to do our little intersection of top minus bottom. So my top function, we're going to have z is between, well, it's between 4 on top, and it's between z equals x squared plus y squared, so x squared plus y squared on the bottom. Okay, now we're going to smush. I'm going to take this region that I'm looking at and kind of smush it onto the xy plane. And when I do, that's where our intersection is going to come into play. So we smush it onto the xy plane and we get this nice picture, a circle of radius 2. This is what the intersection of those looks like. And specifically, we're going to be looking at everything inside of it. So now I want to come up with a way to talk about this. We're once again going to do, so I'll call this like A. We're going to find intersections, sort of. And then we're going to do top minus bottom. Intersection seems like kind of a weird word here. But what we notice, I think if we look at top minus bottom, that might help us figure out what exactly we mean by intersections. Because what I notice is that my y-coordinate, we could solve this here to get y squared equals 4 minus x squared, which tells us that y equals plus or minus square root of 4 minus x squared. This top part is y equals 4 minus x squared, square root of 4 minus x squared. This bottom part is y equals negative square root of 4 minus x squared. So what I have here is I have that y is between positive square root of 4 minus x squared and it's between that and negative square root of 4 minus x squared. Okay, so we have our top and bottom. And now the question is, where do these curves intersect? Well, they intersect at x equals 2 and x equals negative 2. Okay, so we found our intersections. Just going back to the very beginning, we found where the two surfaces intersected. Then we did some top minus bottom stuff. Then we looked at that intersection, kind of smushed it onto the xy plane. We found where the two quote-unquote curves we had, even though it kind of looks like one curve, we found where those intersected, and then we found what the top minus bottom is there, what's y between. And now we're going to smush again. You really don't need to smush here, but we're going to just for the sake of consistency. And now we're really just smushing onto the x-axis. What does this region look like when you smush it onto the x-axis? Well, it's going from negative 2 to positive 2. So we have that x is less than or equal to negative, or greater than or equal to negative 2, less than or equal to positive 2. And now, with these three inequalities we have, we are ready to go ahead and set up our triple integral. So we're going to have three integrals, and our inner integral is going to be the one that has the most variables in it. It's going to be our z. So z is going between x squared plus y squared and 4. And then, so we're going to have our integrand was x, y, z. So since that was what z was going between, dz is going to be on our inside. Then y is going between negative square root of 4 minus x squared and positive square root of 4 minus x squared. So that's dy. Then x is going between negative 2 and 2. That's going to be dx. So we have now set up the triple integral that we could calculate in order to evaluate this integral. So there you go.